Okay, so if you're taking any sort of algebra class, you're absolutely going to need to understand this. So what am I talking about here? Well, of course, this is a formula and it has to do with this little m right there. And for those of you who recognize this formula, go ahead and put your answer into the comment section. But let me give you another little equation here, y equals mx plus b. Hopefully all of you recognize this, but this m here in this equation, y equals mx plus b, is the same m I'm talking about right here. And of course, the answer is the slope. We're going to be talking about the slope of the line. And again, you absolutely need to understand the slope of the line in order to pass algebra. And I have a very difficult time getting through any algebra course if you don't really understand the slope. Now, there's a couple little things that can trip you up when you're dealing with the slope. A lot of you out there probably might say, oh, no, I understand the slope. But I'm going to tell you right now, a ton of people make errors when they're calculating the slope, and I want to make sure you don't make these common errors. Of course, I'm going to go through all of this just one second, but first, let me quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher, and I'm telling you, after years and years, decades of teaching mathematics, all students can be successful in math. Okay, that's what I truly believe, but it requires two things. One, you, the student, have to be willing to put in the work. Okay, so that's the first thing. The second thing is you need great math instruction, clear and understandable, and that's where I can help you out. So if you're at the middle school, high school, or even college level and you need assistance in mathematics, I'm going to leave a link to my math help program in the description of this video. Please check this out. It will help you out tremendously. Also, if you happen to be preparing for any sort of test that has a math section on it, I'm talking about things like the GED, SAT, ACT, ASVAB, teacher certification, those type of tests. I have a ton of test prep courses that can help you out. Also, if you homeschool, I have great middle and high school math courses for homeschoolers. And if this video helps you out, help me out by considering liking and subscribing to my channel. I've been on YouTube for 10 plus years. I have over 1,000 plus math videos. So if you like this video, please check out the rest of my videos. But anyways, let's get into the slope of a line. And I want you to be asking yourself as I review this, how much do you think you know about the slope of a line? It's extremely important that you know a lot. But let's go ahead and start from the very basics. So here is what we call a linear equation, and it is in what we call slope-intercept form, y equals mx plus b form. So this 2 right there is the slope of this line, okay, which you can see here is at the same, it's at the same position as this m. Now, I'm not going to be talking about y equals mx plus b too much in this particular video, but just so you know, what we're talking about is the slope of the line and how you would identify it in this particular equation. So what is the slope of the line? Well, kind of a more just basic common sense description would be, well, the slope. Are we talking about the angle of a line, the slope, you know, how steep the line is? And yeah, that's absolutely what we are talking about. So here is a line, and you can see it has a certain angle to it, certain steepness to it. We call that the slope. Okay, that's what the slope is. And this particular line right here, let's say, has a slope of 2. Okay, so for example, if I was to graph this line, its slope would be 2. So the slope is a number. It's represented as a fraction generally, and you're going to see here in a second. But it's lines that go from that increase from left to right like this, that go kind of uphill, have a positive slope. So lines that go downhill like this, all right, have a negative slope. You need to understand this, okay? So lines that increase this way will have a positive slope, like a positive value. Lines that go down this way will have a negative slope, so something like this, y equals negative 3x plus 1. Okay, so you can see here that the slope is negative. Now, let's do another one here. How about lines that are horizontal? Okay, flat lines right here. What do you think the slope is? If you said the slope would be 0, you would be absolutely correct. So horizontal lines have slopes of 0, and then vertical lines like so have something called an undefined slope. So the slope is undefined. There's a lot of reasons why that is. Well, not a lot, but I can explain this in a couple different ways. Right now, this is just going to be a basic overview on the slope. So I'm going to be covering a lot of different things here fairly quickly, but just know that lines that are vertical have an undefined slope. Lines that go this way, that increase from left to right, have positive slopes. The lines that fall have negative slopes, and then horizontal lines have a slope of 0. So these are basic concepts about the slope that you need to understand. But let's go ahead and get into the slope equation here. So let's take a look at our line, okay? Now let's consider 2 points that are on this line. So for example, we could have a coordinate right here, this point that's on this line. Maybe that would be the point 4, 5, and then down here, maybe we have the point -6, -1, something like that. So these 2 points would be on this line. So this formula here represents the points that would be on this respective line. So I'm going to get into this in just 1 second and how we interpret this formula to calculate the slope of a line. Now, before I do that, I want you to understand that what we're going to be actually calculating in this line, the slope, really represents the rise over the run of a line. So let me go ahead and show you this right here. And a good way to think about the rise and the run of a line is to kind of think of a triangle being formed under 2 particular points like this right here, okay? So if you could see, this line is increasing. It's running out so much right here. That's the run. And at the same time, it's rising up a particular amount, okay? So the run of the line goes this way. The rise of a line either goes up or down, depending upon whether it is a positive or negative slope. But this little ratio, the run to the rise, it basically indicates or shows the slope of the line. Okay, as long as I kind of form a triangle, this is the rise, I'm sorry, this is the run, and this is the rise. So long as I know the run and the rise, I can go ahead and build this triangle, which would actually graphically show me the slope of that line. So when you're calculating the slope, you are calculating the rise over the run, okay? Now the rise right here is the change. If you notice, the rise is going in what direction? It's going in the direction of the y-axis. So the rise is oftentimes, let me go ahead and write this way, is referred to as the change in the y's. Now what y's are we talking about? We're talking about the y coordinates of a line. So here's y and here's y. So we have 2 different y coordinates. So if we subtract them, that's how we're going to find the change in the, basically how we're going to find this part of this triangle. It's the change in the y values, okay, or change in y. And then the run is we're going to subtract the x values. That's how we determine the run of a line. And of course, you can see that runs along with the x-axis. Okay, so put that right there. So the rise over the run is the change in y over the change in x. And you can see, again, I can find the differences of the y's. That's going to be my rise. That's how this formula works. Over the differences of x, this is going to be my run. Now, I am going through this fairly quickly. If you need additional kind of practice or more comprehensive instruction on this, I'm going to suggest that you check out any one of my algebra courses, starting from pre-algebra, algebra 1, whatever you might be. And I do have additional videos on my YouTube channel in my pre-algebra and algebra playlist. Okay, so that's basically this equation for the slope, or the slope formula. But now let's go ahead and put this into practice, and we'll do an additional problem here in just 1 second as well. All right, so let's say we want to find the slope of this line, a line that passes to the point 4, 5 and -6 and -1. Okay, so I have my slope formula right here. So I want to find the differences of the y's. Okay, so where are the y values? So this y2 and y1, all this says is that there's 2 y values in these points. So here's one y value, and here's another y value. Remember, a coordinate on or a point on the xy plane we describe as xy. Okay, it's an ordered pair. X is first, y is second. So 5 is a y and -1 is a y. So if we subtract those, that's what this is saying right there. Okay, find the differences of those y's. So we're going to go 5 minus a -1. 5 minus a -1. Okay, we're just following the formula right there. Now, once we've got this set up, we need to find the differences of the x's. So the x's are what? 4 and negative 6. We got to be very, very careful using this formula. So this will be 4 minus a minus 6. Now, this is set up correctly, but I'm going to show you here in a second how you need to really work these problems. And we're just kind of applying the formula here, but let's go ahead and finish this up, and then I'm going to talk about some common errors that students make. So 5 minus minus 1 is going to be 5 plus 1. Okay, got to know your positive and negative numbers for sure if you're dealing with the slope. And then 4 minus a minus 6 is going to be 4 plus 6. So this would be 6 over 10, or if we reduce that fraction, 3/5. So this slope of that line is a positive 3/5. Now, let's go ahead and write this in here. Now, let's just look at this. Does that make sense? Yes, it does make sense. It's positive, so that means that line is going in this direction. So that means for every, this, again, the rise over the run. So for every 5 this line runs out, it rises up 3. That's the ratio of increase for this particular line. So again, you want to know more than just how to calculate the slope. You want to understand the bigger picture behind what the meaning of the slope is. Okay, so now let's get into another problem here. So let's suppose I asked you to find the slope of a line that runs to the point 2, 7, and 5, negative 1. Okay, so what do we need? Well, we're going to use our formula. So this is going to be the differences of the y's over the differences of the x's. Okay, so what are the y's here? Well, 7 and negative 1 are the y's. Now here is what I want you to do. Okay, notice in this particular setup here, I'm saying 7 minus minus 1. I'm taking this 7 and I'm going to subtract away this negative 1 here. Okay, that means that I'm finding the differences of the y's. No problem, that's perfectly okay. But when I find the differences of the x's, notice I'm taking 2 down here and I'm writing 2 first. Here's what I want you to do. When you're finding the slope of a line, underline one of the coordinates. Okay, I'll show you the reason why in just one second. So I'm going to start with this point's information first. So I'm going to start with the 7 first, and then I'll subtract away this y. And then I'm going to subtract with this, I'm going to start with this x value here from the same point. Because I started with the 7, I got to start with the 2 down in the denominator. So that's going to be 2 minus 5. If you don't do this order correctly, in other words, let's say you go 7 minus minus 1, and then you go, all right, we took this 7 and subtract away from this negative 1. Now you said, well, I'm going to take this 5 and subtract from 2. So like this, 5 minus 2, you're like, well, it's the same thing as subtracting x's. You will get the answer wrong. You'll get the signs wrong. This is one of the most common errors for algebra students when they're calculating the slope. So let me just be very clear about that. Doesn't make a difference what point you start with. Just pick one point. So here I'll start with 2, 7. So that means I'm going to start with this 7 minus this y right there, and then I'll start with this 2 minus this x. Okay, so you can kind of see that setup. And when you do that, I got 7 minus minus 1. Of course, that's going to be 7 plus 1, or 8. And then 2 minus 5 will be negative 3. So this would be negative 8/3. Now let's suppose I do the same problem, but now just to kind of show you that this works the other way, let's say you wanted to just start with this point's information. No problem. We'll find the differences of the y's. So that's going to be negative 1 minus 7. Negative 1 minus 7 right there. That's the differences of the y's. Now the differences of the x's, remember I start with this point. I'm going to have to start with this 5 down here. So that'll be 5 minus 2. So this is the setup here. So negative 1 minus 7 is negative 8. 5 minus 2 is positive 3. Negative 8/3, negative 8/3. We have the same answer. Okay, so don't worry about what point to pick. Just underline one point and apply the slope formula. But this is probably one of the most common mistakes that algebra students make. I see this happen over and over and over again. So if you understand everything I kind of laid out in this video, well, then you're going to be head and shoulders above the average algebra student out there. I'm telling you right now, a lot of students struggle with the slope. They think they know it better than they actually do. But again, all these little details is what really matters. So hopefully this video helped you out. And again, if that is the case, please help me out by liking and subscribing to my channel. Again, if you need math help, okay, check out my math help program. You can find the link to that in the description of this video. But with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.